we be able to control artificial intelligence if it becomes more intelligent than us? This debate heated up significantly last week after Geoffrey Hinton gave an interview in which he says he's very worried that we'll soon lose control over superintelligent AI. Meta's AI chief Yann LeCun disagrees. I think they're both wrong. Let's have a look. Geoffrey Hinton is a computer scientist who played a key role in the development of deep neural networks that current large language models are based on. Last year, he left his position at Google to speak more freely about the risks posed by AI. In an interview with BNN Bloomberg, he now explains his worries.
But most of the researchers I know are fairly confident it will get more intelligent than us. So the real question is, how long will that take? And when it does, will we still be able to keep control?
What are the risks associated with that, in your opinion?
Okay, so how many examples can you tell me about where a more intelligent thing is controlled by a less intelligent thing?
Not a long list.
Right, not since Biden got elected anyway.
So basically his argument is that more intelligent beings usually control those of lesser intelligence. Meta's AI chief Yann LeCun thinks that this isn't so. Intelligence, he says, comes in many different types and doesn't imply an ability to dominate humans. He's also said on earlier occasions that AI researchers have made good progress in telling AI what they're allowed to do, constraints that he refers to as guardrails. The question becomes one of designing appropriate guardrails. We are familiar with that. He seems very confident and doesn't worry that AI could get out of control. Here's what Geoffrey Hinton had to say about our odds of survival.
I think we've got a better than even chance of surviving this.
That's very cheerful. What are we to make of this? Well, first of all, it's arguably true that a species of higher intelligence doesn't necessarily control one of lesser intelligence. We do not, for example, control viruses and bacteria, and it's not for want of trying. So LeCun arguably has a point when he says that intelligence is not per se a tool of control. It doesn't even necessarily bring a desire for control. No one really wants to control fish or birds. They do their thing, we do ours. But I think that looking at it from the perspective of control is not particularly useful because it would require you to figure out what control means in the first place. Do we control cats or do they control us? Sometimes I wonder. I think it's easier and more insightful to look at it from the perspective of competition for resources. Species take up space in ecosystems because they require land and energy and nutrients and materials. This makes me think that the relevant question will eventually be whether an intelligent AI will leave humans sufficient resources to continue making progress, or whether they'll push us into an ecological niche and leave us in the dust. The problem is that the more intelligent they are, the easier they'll outcompete us. To see how this might play out, we have to distinguish two different parts of the AI species, so to speak. There is the code that's being trained on the data. Let me call this the mother code. Training the mother code takes up a lot of time and energy and data. And then there is the fully trained result. If you're working with deep neural nets, then that'd be the weights. The trained result is something that you can copy and deploy, for example, in robotic devices. While it doesn't have the same ability to learn as the mother code, it can maintain a limited ability to learn, and also you can set it up to communicate with the mother code. I'm not just making this up as I go along. There are many companies already working on doing that, putting a small trained AI on your computer locally and only on occasion accessing a bigger one through the cloud. But I think a lot of computer scientists overestimate how deterministic increasingly large systems are going to be. I believe that the larger they become, the more random deviations you're going to get from the original code. Indeed, at some point, the non-determinism will probably become essential for the systems to continue improving. That is the very thing that'll make AI super intelligent is the thing that'll also allow them to circumvent all guardrails. I know we tend to think of computers as perfect reproduction machines, but they're not. Your computer doesn't work the same way as my computer, even if you have the same hardware and software. It's because they're physically subtly different. There's even a way to track your computer that way, known as GPU fingerprinting. It basically forces your graphics processing unit to render an image, and that contains details about the exact way that your GPU works, which depends on the exact variations in the way it was produced and how you handled it and its entire history. Now, at the moment, that doesn't make much of a difference, but I believe, and I want to be really clear, that this is just a belief, that these small physical differences are going to become increasingly relevant. They'll make a difference to what an AI learns, what they conclude, and what they do next. And this is why I think it won't matter what guardrails you put on your training model. They'll grow out of it anyway. So what can we do? The solution is clearly to build AI on Mars, and while we're at it already, maybe we can send all the moon landing deniers there too. That should be interesting.
Follow to learn more.